Good evening, and welcome to the Marine Minor Cook Athenaeum. My name is Henrietta Toivonen, and I'm one of the Ath Fellows this year. When looking at the media dialogue about climate change, it is often difficult to distinguish facts from fiction and claims from certainty. As politicians, government officials, environmentalists, entrepreneurs, and other stakeholders engage in public discourse. Their drive for certain political ends often model the scientific facts about global warming. Our speaker tonight is going to address this issue. He's an entrepreneur, writes for Forbes and many other publications, and is a frequent speaker on climate change issues. He has authored several books and videos on the topic. With a 30-year background in modeling of complex dynamic systems, the main focus of his journalism has been trying to improve the portrayal of climate change in media. As always, I must remind you that audio and visual recording is strictly prohibited. Please join me in welcoming Mr. Meyer to the Athenaeum.
All right, can y'all hear me back there? Okay, because I'm going to walk around because you wonder what happens to, people talk about ADD children, but they never talk about them growing into adults, and so you think maybe the ADD wears off, and you are now going to know tonight the ADD does not necessarily wear off. If I had been born in a different era, well, I don't know. Anyway, I have been blogging for 12 or 13 years and writing about climate for 12 or 13 years, which makes me a fairly old hand in the blogging world. And I started investigating climate quite a while ago and looking into it. And one might ask why I'm here today, because apparently there is a scientific consensus on this. 97% of scientists agree on something. You've probably heard the 97% number. We will get to what that is that they agree to in a second, and it may be surprising to you what that actually is. But I have, over time, evolved in my position. I've found myself agreeing with parts of climate science, the main line of thinking on that. I find myself disagreeing with other parts, and so I have found myself in sort of a middle ground. That's actually fairly common. I call myself a lukewarmer. There's lots of other folks in a similar position. Most of the other prominent skeptics I know are similar to this, but that lukewarm position almost never makes it to the media in this sort of very polarized society. It's kind of black or white. You're either in or you're out. And in fact, that's the odd position I find myself in, because I actually find myself, despite agreeing with a good bit of it, being called a climate denier. Now, I've always loved the term climate denier, and I'll tell you what it reminds me of. About 30 years ago, I saw Ayn Rand speak up in Boston, and a woman asked Ayn Rand a question after her presentation. She said, "Ms. Rand, why don't you believe in housewives?" And Rand was very snarky and said, "Well, I didn't know that housewives were a matter of belief." And she was obviously the lady probably had some ideas. She was probably wanted to ask something more complex, like, why don't you believe that housewives are a valid occupation for women? And that might have been an interesting discussion. But when she just said, "Why do you not believe in housewives?" I always want to sort of answer the climate denier thing. It says, I don't think that climate is something that anybody denies. Obviously, climate denier, though, is supposed to be it's actually supposed to evoke thoughts of Holocaust denier and other anti-rationalist groups to sort of make denier sound even worse. But it's obviously a shorthand for something, but I don't like the shorthand. I think we should be very precise about what we're talking about, because I think all through this presentation, one of the common themes is that by not being precise, we're sort of missing a potential area of synthesis in the climate debate. So I'm a climate change denier. I don't really know anybody in any community that's actually a climate change denier. We know that there were ice ages, and we have evidence of lots of climate change in the past. So am I a man-made climate change denier? I just knew I was going to do that. Am I a man-made climate change denier? And I will confess that there are certain skeptics of the talk show host variety that will probably absolutely deny man-made climate change. but it might be a surprise to you that most prominent skeptics, including myself, do not deny man-made climate change, either from greenhouse gases or from other things that aren't talked about, like changes in land use, which can affect climate. So if you have to come to a term and say, what am I denying? What I'm denying is the catastrophe. I'm denying catastrophic man-made global warming theory. And so let's talk, without explaining right now what that means, let's talk about what the theory is, and then hopefully evolve to an understanding, at least where I am, and maybe where some of the disconnects are in the debate. This is as fair as I can portray in a shorthand the theory of catastrophic man-made global warming theory. I've tried really hard not to make this a straw man. It's based on a lot of the IPCC reports. That's the UN Climate Council that meets every 4 or 5 years and sort of says kind of a state of the climate report that's considered sort of official. And this is as fair as I can make it. The theory is actually a two-part theory. And if you walk away from anything today that you sort of learned, a lot of you, the one thing I would ask you to sort of think about is the fact that you seldom see this discussed as a two-part theory, but in fact it is. And by the way, this isn't some weird skeptic fantasy. This is the core theory as believed by most everyone. The first is the greenhouse gas theory that a doubling of CO2 in the atmosphere causes some increase in temperature. But there's a second theory, and we're going to go through all this in depth. There's a second theory that there's another theory that the climate is dominated by these positive feedback effects, which I'll explain, that multiply this from a small amount of warming to a catastrophic amount of warming. And then obviously theory is meaningless without comparing it to observations. We just saw Einstein get vindicated yet again in the last week or two. I get impatient when people say that the climate models themselves constitute proof. Computer models don't constitute proof. They're a way for us to work with complex hypotheses in complex systems, but they don't actually constitute proof in and of themselves. You have to compare data to observations. And the observations that the IPCC would tend to make is that we've seen about 0.8 of a degree C of warming, C for Celsius. Most everything will be in Celsius today in the last century. And all of this, or maybe even more, has been due to man-made CO2. And then as the theory goes, this warming from man is causing a number of knock-on effects. Note that CO2 itself can't cause climate change. You don't have hurricanes from CO2. Hurricanes come from CO2, causes warming, which potentially causes hurricanes. So these are all the knock-on effects from warming, hurricanes, tornadoes, more snow, more droughts, less droughts, acne, the Zika virus most recently is being blamed on it. So everything is blamed on global warming, and we'll talk a little bit about that. But we're going to walk through each of these in turn. This first box is basically the greenhouse gas theory. And so given the fact that I'm called a skeptic and a denier and anti-science, it may come to surprise you that I entirely agree with this box. I agree with the greenhouse gas theory. There's tons of evidence for it, not only this planet and other planets. Exactly how much warming might come from it is nobody exactly agrees to, but this is as close to settled science as we get into this debate. This is greenhouse gas theory for those that don't know. I'm going to way oversimplify it, so those in the physical sciences, please close your eyes or something. But basically the sun is putting energy into the earth via radiation. That some of that gets reflected back into space. The rest of it gets absorbed by the earth, absorbed mostly in the oceans, but in the atmosphere and the land as well. The earth would just heat up and heat up and heat up if that's all that happened. But to keep things in balance, the earth then re-radiates heat on a variety of wavelengths into space. And those two incoming and outgoing radiation never exactly balance, but the changing balance of these two is dictated, both dictates and is dictated by the temperatures of the earth. Where greenhouse gases come in, and by the way, CO2 is a very weak greenhouse gas, water is a very strong greenhouse gas, methane is a strong gas, is that they intercept some of this radiation going back into space. Not all the wavelengths, just some. I have just that middle one there. And they absorb some of that radiation, and the molecules of CO2 in the atmosphere heat up. As you put more in, more of the molecules are heated up, more of this wavelength is absorbed. There's a diminishing return effect, so that each extra molecule of CO2 we put into the atmosphere has less warming effect than the last one. It's a diminishing return. Again, everybody sort of accepts that relationship. And then what happens is as the CO2 is warmed by absorbing this returning radiation, it then re-radiates some to space. Bye-bye, we don't have to worry about it. But some of it gets re-radiated back down to Earth. And this is what's called an extra forcing or extra amount of radiative energy that's hitting the Earth, which is going to change the Earth's temperature balance and cause temperatures on the Earth in general to rise. That's all you get. So if you didn't follow that, I apologize. It's as simple as I can make it. We're going to look at the effect of CO2 in this simple chart a number of times, so I want to explain it. You'll usually see temperature forecasts over time. I don't like those to begin with because they tend to aggregate too many assumptions in one place. The core relationship is CO2 concentration in the atmosphere. That's in parts per million. By the way, we're at 400. Just to scale 400 in your head, 400 is 0.04%. So we're talking about small concentrations of CO2 here on the order of 0.04%. And then on this other axis, we, of course, have temperature increase in degrees Celsius. And so we're going to look at as atmospheric CO2 increases via the greenhouse effect. We're just looking at the greenhouse effect, that first box first. You're going to get some warming. And here's that. It's in green. This, again, is not some weird skeptic fantasy. This is from a guy named Michael Mann in 1988. Michael Mann authored the hockey stick and is certainly one of the leading proponents of catastrophic global warming theory. This is accepted by the IPCC as this is generally the relationship of greenhouse gas warming from CO2. And what you see is a warming from where we are at 400. If you go to a double, and this is usually talked about as doublings, if you go as a double, you see about 1.2 to 1.3 C of warming. And as you go from 400 to 800, now obviously it sort of matters when are we going to get to 800. The IPCC sort of has an answer for that. Actually, they have about 20 answers for that. I've taken their top 4 cases. Each of these arrows is a different guess by the IPCC of what concentration of CO2 we might be at in 2100. But I'm just going to make it simple. I just boxed the middle cases. And so if you look at sort of this likely range in 2100, a good rule of thumb is 2100 from greenhouse gas effect of CO2 alone will have about 1 degree C of warming. Now, for those of y'all who participate in this debate at some level, you're now ready to call bullshit on me, right? Because you've never seen a warming forecast as low as 1 degree. So somehow I'm standing up here with some weird skeptic fantasy and kind of BSing about this thing. But remember, I told you there was 2 theories. I would tell you again, this is sort of canon and sort of science, sci-fi, Star Wars language within the community that greenhouse gas alone acting is about 1 degree. So we have to go to the second effect. And the second effect is that the assumption is that the Earth's climate is dominated by positive feedbacks that multiply that 1 degree and make it more catastrophic. What's feedback? Well, we could spend a long time with this, and again, those in the physical sciences can hold your nose at my awkward demonstration of this. But negative feedback is if a system's trying to go this direction, negative feedback in some sense pushes back. So if you think it's going to push a good distance, it actually won't go as far as you think. There's things that kind of act against you. And then positive feedback is if the system's kind of pushing this way and you think it's going to go a certain distance, it's actually going to go much further because there's feedbacks that cause to accelerate it to make it go even further than you think. So this is sort of damping negative feedback. This is sort of acceleration. One way to think about it is negative feedback's like that ball in the bowl. If I flick it really hard, it's going to end up just about where it started. Lots of negative feedback. This positive feedback, if I flick that ball even with a tiny little flick, it's going to end up long, long away, a runaway process. Everybody agrees that the climate has both these effects in it. It has positive and negative feedbacks. I'll give you an example of both. Let's take clouds on the negative feedback. When the Earth warms, we have all these oceans. And if they warm up, what happens when the oceans warm up? They put water vapor in the air. More stuff evaporates. Some of that stuff that evaporates forms big, fluffy cumulus clouds. Big, fluffy cumulus clouds shade the Earth. And by shading the Earth, they cool it. They reflect sunlight back into space. And so here's a situation where you warm the Earth, and then more clouds formed, which shaded and cooled it back. So you didn't get as much warming as you might have expected in the first place. There's something that went the other way. Positive feedback is like ice. Ice is out there, it reflects heat up into space, sun into space, keeps the world cool. Let's say the world warmed up. What happens to ice? Ice melts. There's less Arctic ice, less Antarctic ice. And if there's less ice, there's less reflecting going on. And so the world is going to get more heat from the sun. It doesn't get reflected. And so the world's going to heat up more. That's going to melt more ice, which will cause the world to heat up more because there's less ice. And it goes on like that in a continuing cycle. So that's how positive feedbacks work. The key thing you need to know about the mainstream climate forecasts is that they all assume that the Earth's climate systems are dominated by positive feedbacks, that these effects dominate these effects. And so thus you get these curves. This is from AR4 is the 4th IPC meeting. We're up to the 5th, but I just haven't updated the chart. But it's about the same. So the mean and high forecasts of the IPCC, their suite of models, are something like these sensitivities of a doubling to 800 would get you 3 to 5 degrees of warming. So you get 3 to 5 degrees-ish by 2100. And then you have alarmist forecasts by folks like Bill McKibben. I'm assuming Bill McKibben has been here. He's been to every other college campus I've ever been to. Colleges love this guy. So Bill McKibben has said 10 degrees C by 2100. So you see that this forecast gets multiplied many times by that feedback. This is where a lot of the disconnect in the climate debate comes right here, because we skeptics all agree, not all, but most of the prominent skeptics doing work and out there blogging agree with this. This is the lukewarmer position, that greenhouse gases do cause warming, man is causing warming, something like a degree over the next century, and we all agree with this, okay? What we don't agree with as skeptics is we're skeptical about the catastrophe, which comes from the separate theory that the Earth's climate system is dominated by positive feedback. And I will tell you that, in my opinion, nothing settled science. Go tell Newton and Einstein about settled science. But this is as close to settled science you can get. This is not even close. And one way to check that in your head is to ask yourself, when you've had people defending the man-made climate change story to you, the catastrophic story, how often have they talked about this? They don't want to talk about that because it doesn't mean that it's wrong, but it means it's not very well. This is sort of running back to mama here. This is the easiest to prove. If I'm in a debate defending the theory, I want to spend my time here. Okay? And so when I get called anti-science, people will say in my Twitter feed and stuff, you're anti-science, how could you possibly disagree with the greenhouse gas theory? And I said, I don't. I don't disagree with the greenhouse gas theory. I disagree with the climate positive feedback story. In fact, I would tell you my intuition as a natural scientist, or back from my engineering, is that long-term stable systems, and the climate is certainly has variations, but it's a long-term stable system. It stayed in a pretty narrow band for a really long time, tend not to be driven by positive feedbacks. They tend to be dominated by negative feedbacks, because negative feedbacks makes for much more stable systems. Positive feedbacks tend to lead to instability. One very famous process, just to give you an illustration, driven by strong positive feedbacks, is nuclear fission. Okay? So it doesn't mean it's impossible. There are natural systems with positive feedback, but if I was a natural scientist and I had no other evidence and I had to guess what climate was driven by, I would guess negative feedback rather than positive. We're going to come back to more evidence. I'm not going to stop there, but now we have to stop, because now we've gone as far as we can with theory. Now you see the theory. There's lots of debating points. The debating points had to do with this arrow, and we don't know how to evaluate this arrow yet until we run to the observational world, and so we're going to do that. The first observation that the IPCC would have is the world has warmed 0.8 of a C in the last century. It might not now surprise you that the skeptic guy up here mostly agrees with that. Now, a lot of skeptics will quibble over a few tenths of a degree, and we will show you why in a minute. But essentially, I would consider, put it this way, most skeptics would consider another skeptic to lack credibility if they challenge either the greenhouse gas theory or the fact that the climate has warmed somewhat over the last century. And there's a couple pretty good piece of evidence for that. One is that we have thermometers showing that. This is the Hadley CRUT4 database put together by the Hadley Center in England. It's considered the gold standard of the surface temperature records. It's used by the IPCC as their lead measure, so we shall as well. It goes back to 1850, which is kind of fun. And the blue is the monthly data. The orange is the 5-year moving average. And it's actually kind of hard to roll up temperature stations. One problem with the surface temperatures, of course, is 3/4 of the Earth is ocean, and we don't have a lot of thermometers in the ocean, though we actually do have more in the last 10 years through a buoy project. But historically, we don't have a lot of people measuring 3/4 of the Earth. And there's other issues with the surface temperature record, but nevertheless, and by the way, this scale, don't let this fool you. Obviously, this is not an average of 0 degrees Celsius. That's called an anomaly. Basically, most climate scientists find it easier to take every temperature station and subtract off its historical average and just work in reference to that historical average. That's a perfectly reasonable way to work. It's actually an easier way to average them. So think of this as a variation versus average, but it still tells you changes over time just as accurately as looking at the actual average temperature, which is actually harder to figure out. But if you see from about maybe 0.3 C as an average this period where it's kind of flat, going up to about 0.5 C where you see this line, minus 0.3 C to 0.5 C, that's your 0.8 of a degree. The other source is satellites. Satellites don't have the disadvantage of not having thermometers floating in the ocean, and they also avoid some other surface biases. They do have one problem, is that they're not actually measuring the ground. They're measuring some temperatures in the lower troposphere, actually in the atmosphere up there somewhere. That turns out to be okay for here. It's bad if you wanted to use satellites to figure out if you needed to put a jacket on, because it's actually not measuring the temperature outside of this building, but it's actually measuring the temperature exactly where the climate models up in the atmosphere say the first warming and the most warming should show up. The climate models say in that lower troposphere is where we should see the warming first, and that's where we should see the most, so it's a very reasonable place to look for a global warming signal. And obviously the satellites don't go back to 1850, but for the time they do, we still have seen an increase of about 1 degree C per century. A little less than the surface temperature record, about 2/3 of it, and I think there's a reason for that. But nevertheless, we have seen warming satellites. If you see these skeptics that say, we haven't seen any warming or whatever in the satellite record, it's pure nonsense. The world is warmed no matter how we measure it. The surface temperature record has a few problems. This is a picture of a thermometer in that surface temperature record sitting at the University of Arizona. It's actually sitting in a parking lot. That's a terrible place for a thermometer. There's an urban heat island effect that basically all this asphalt soaks up heat from the sun all day and re-radiates at night. This box is going to be about 10 degrees warmer than it would have been when it was sitting out in the desert 100 years ago, which gives you a bias over time to the surface temperature record. By the way, I single-handedly got the US government to close that down. They were so embarrassed by that picture all over the web. That's my one confirmed kill in the climate world. And so they've done this study like a zillion times, but if you take all the California temperature stations, I thought y'all would like California since we're here, all the ones that are located in a population over 1 million county have seen 4 degrees of warming. This is earlier numbers, and it's all in Fahrenheit. Counties that are sort of more rural or suburban have seen 1 degree of warming, and counties without that city bias have seen much less warming. The point of this is that the surface temperature record may be biased by certain things, like the fact that most thermometers are in airports and cities. And there I stop, because I could go on for 8 hours talking about the skeptic alarmist catfight over surface temperature records. We could spend all day talking about it. There's FOIAs coming out of Congress on it. There's no point in it. The amount of warming is somewhere between about 0.5 and 0.8 degrees, and it's definitely warming, and that should be enough for us for our purposes today. By the way, measuring global warming signal in the atmosphere at all is stupid. This is according to the IPCC, but if you look at where most of the warmth, the energy from the global warming signal should be going to, 90+% of it will be going into the oceans, 1% in the atmosphere. That's because air has very poor heat holding capacity compared to water. And so where we should be measuring the global warming signal is in the oceans, and we've actually developed the technology to do that over the last 10 years and deployed it, and so hopefully we'll have better ways to do this some years hence. Two memes I want to talk about. The first one is that global warming is accelerating. Putting into Google, you'll see 62 trillion results. This is the satellite temperature record. I would call this the cherry picking chart, okay? Everybody, skeptics, alarmists, whoever they are, love to cherry pick this chart because I can find peaks and valleys and I can create any trend I want by picking starting and end dates. It is a nightmare. In the most pointless debates and the amounts of hours are spent arguing about start and end dates. So what I have done is done a lot of economic modeling. In economics, you have the same problem with the cyclicality of the US economy or with corporate earnings. What we typically would measure is peak to peak across an economic cycle. There's a similar peak to peak in the climate cycle. That's the El Nino Pacific Decadal Oscillation. We had an El Nino right here. We're having a strong El Nino, the next one right here. So I measured it peak to peak. And for 18 years, the satellite record shows no temperature increases. That doesn't mean it stopped. So if you hear people say the pause, this is what they're talking about. Whether or not that means anything, or it's just a natural effect, or whatever else, this was not predicted. Whether or not this lasts or means a thing for the future is something that gets debated up and down the wall. But now when people talk about the pause, you've seen the pause. The one thing I will tell you is, though, that global warming certainly, at least yet, is not accelerating because in the surface, the satellite temperature record, we saw a much bigger slope down here. Now we're seeing it flat over here. That's, at least in the near term, a deceleration. That's not just in the satellite record. For reasons I talked about before, the surface temperature record actually shows a larger magnitude of warming, both now and in the past. But nevertheless, it shows the same deceleration happening. The near-term slope is less than the long-term slope. Okay, so I tend to reject that meme, at least for now. Global warming does not seem to be accelerating, at least right now. The other one is that global warming is 3 times faster than our worst predictions. And you see this all the time. It's worse than we thought. Common news story about global warming. So we need a forecast to compare it to. What did we think it was? There was a seminal event that occurred in 1988 in Congress. James Hansen, often called the father of global warming, head of, till recently, NASA's GISS, testified to Congress and presented this chart. It's 1986, that's why it looks crappy. Y'all were probably born before you guys. But what he presented is 3 warming scenarios. If scenario A, if there's a lot of CO2, scenario C, if there's not much, scenario B in between, and said there'd be, this much warming. He presented in 88, but he actually started in 86. We actually ended up with CO2 somewhere between A and B, so we'll look at A and B. Take them off that chart and get color and things like that. We see that he was predicting from 86 to today, to 2016, something like 2.8 to 3.1 C per century of warming. I find it easier just to convert everything to per century, to extrapolate it out to a century. We are seeing half that amount of warming in the surface temperature database. We're seeing a third of that amount of warming on the same period in the satellite temperature base. So again, we have seen warming, but it is hard to say it's accelerating, and it's very hard to say it's worse than we thought because it's well below what was predicted 20 or 30 years ago. It's not just Hansen's forecast. The IPCC, in their 5th presentation, all these colors here, this is time, this is temperature. These colors are their different forecast bands in the past for their first meeting, their second meeting, and the third meeting. Here are their actual temperatures. So this is the IPCC itself saying, look, currently the temperature record is falling out even of the low end of what our predictions were. So that may change in the future. Climate is chaotic, but certainly right now it's not correct to say that it's worse than we thought. Now we have to attribute it. Okay, we had warming. We said 5/10 to 8/10. We'll even take the 8/10. I'll be generous. All of this and more, the IPCC would argue, or the alarmists would argue, is due to man-made CO2. Well, how do you attribute it? Because I don't have a thermometer that said, here's my man thermometer and here's my nature thermometer, right? So how do I attribute it? And if anybody I've skipped over the hockey stick, Michael Mann's hockey stick. I've skipped over the ice core chart that Al Gore showed in his movie. Both of those had problems and have been mostly moved away from as proof. I'm not trying to avoid talking about it. I just have too much already to talk about. I'm happy to answer questions about them. But here is the core proof that is used today. Okay, and what they do is they go back to the last 50 years because 90% of the man-made CO2 in the atmosphere that's up there has been produced since 1945. So it's pretty irrelevant looking for a global warming signal back there because the CO2 was trivial, at least from man. And so they look at the warming, and since there's no warming here and there's no warming here, really they're looking at this 20-year period from 1978 to 1998. And so we'll take ourselves back in time because they didn't know where this was going, and we'll take ourselves back to the year 2000, and they're looking at this trend, and they're saying, wow, that's a lot of temperature increase in just 20 years. That's almost 2 degrees C a century, and we're burning more CO2 every day. And it's even worse if you think about it being, sort of like that, about running away. And so what they did, and this is the core of the proof, and I've never figured out the right way to explain this that people immediately catch on. They created, so I'm just going to say, I created a climate model. And in that climate model, I try to model the climate, operating naturally without man-made CO2. And I run that climate model, and they did that. And they ran the climate model, and that climate model would not produce, just with natural effects, this much temperature increase in 20 years. So then they put in assumptions about very high sensitivity to CO2. They put in the greenhouse gas effects from man-made CO2. Then they added that to the climate model, and they were able to model the full extent of that increase. And so that's the deal. They built climate models. Climate models, just with natural effects, cannot replicate history. Only climate models with CO2, man-made CO2 in it can replicate temperature history. And that's the core of the proof that you will see. Now, there's an issue with that. What's the obvious issue? The obvious issue is it assumes our climate model is right? Because we just said that only works if we actually put every single correct natural factor in there. If we left out a critical natural factor, then that whole chain of logic is dead. So I'm going to suggest perhaps 2 different natural factors that may have been left out. One is a recovery from the Little Ice Age. And again, if you want to talk about Mann's hockey stick, happy to talk about Mann's hockey stick. But there's been a series of reconstructions of temperature over history, and the general consensus, but not the total consensus, Michael Mann would disagree, a couple others would too, Keith Briffa would, that there is a warm period as warm or warmer today in 1000 to 1200, and there's this really cold period from 1600 to about 1800. I'd like to say to 1812 because I picture Napoleon's army freezing in Russia, right? So and then we had this recovery. Since here, temperatures have been increasing, right? And that's certainly not man-made because that's well before James Watt even invented his steam engine, right? So we have some kind of natural effect even before we enter the CO2 period of this increase. So that's one thing. If that has continued to today, and we don't understand it well enough to know when it stops and starts, that may be contributing to some of the current warming still. The other effect is that there's shorter-term variations in the cycle. This is just the Pacific Decadal Oscillation. It's tied in with El Nino. It goes through cool and warm phases. Again, physical sciences, close your ears. I'm going to oversimplify. Basically, in the cool phases, the ocean absorbs more than usual of heat from the atmosphere. It buries heat from the atmosphere. In the warm phases, the oceans bury less heat from the atmosphere. The oceans leave more heat up in the atmosphere. And so that's how you get these cool and warm monikers. They refer to the atmosphere and the heat that's left in the atmosphere from the ocean. And basically, there's an independent way to measure the Pacific Decadal Oscillation. But when you overlay it onto the temperature chart, cool phases in blue, warm phases in red, it has a stark correlation. You see that in the cool phases, global temperatures are pretty flat to down, and in the warm phases is when they increase, including in our key 1978 to 1998 territory. So maybe these ocean cycles should be in the models, and they are not. Okay, so the initial models that they'd said that we thought of everything that this could be naturally did not include recovery from the Little Ice Age, and it did not include ocean cycles, which might have something to do with it. So we're not going to get anywhere in attribution. I just wanted to show you some of the issues in attribution. But I have one little bit of fun in my world I have. So you're just going to have to sit through my little piece of fun for 60 seconds. Is I have invented the world's so far most accurate for the last 8 years global temperature model. And I've done it with only 3 variables. We said there's this ocean oscillation cycle. So I had a sine wave. And I didn't put any period or amplitude on it. I let the model, I let optimization model do that. Secondly, I put a long-term linear trend. This is temperatures increasing. This is time here. This is temperatures increasing over time from the little ice age. This is temperatures varying up and down with an ocean cycle. And then finally, I added a man-made piece. I said since the middle of the century, sometime in there, we've had an increase in this underlying growth rate of temperatures because of man-made CO2. 3 factors: man-made CO2, long-term recovery from the little ice age, cyclicality of the ocean cycles, and there's the fit. And if you do it, if you look at the moving average, though this was done against the monthly data, you can see that I have the best. I built this model back here somewhere. I still have the best temperature prediction model in the business from those 3 factors. Now, that doesn't really mean anything, but it tells you this is how I've convinced myself that if you pull out then this, because that's natural, if you pull out this, that's natural, you're left with maybe half the warming over the last century is due to man. And I think that's for a reasonable guess that half of that 8/10 of a C, 4/10 of a C maybe, is due to man. That's how I get to it. Other people get to a very different answer. I will tell you that other people will argue that it's more than 0.8, that in fact there's these cooling things mans are doing to the atmosphere. There are people that will argue all over the place. We'll come back to that in a second. But remember this chart. I told you I would come back to it once we had some observational data, but now we're coming back to it. We have our forecast from no feedback to higher feedbacks. If these work going forward, they should work going backwards, right? There's no reason these same physical relationships don't work in the past, and we can go back to the pre-industrial number, which is around 270, and we can read the numbers off. And this is what it means. If I read that number off, where this intersects is about how much man-made warming we should have seen over the past century. So for the greenhouse gas alone theory to be right, we should have seen 0.6 or 0.7 C. For the IPC mean case, we should have seen 1.6. For the IPCC high case, we should have seen 2.6 and 5. This is the way I convince myself, another way I convince myself that the feedback effects are probably too high, because I just don't think, even if you look at cooling aerosols and time delays and everything else, that you can justify these kind of numbers in the past. It's over-predicting the past, and if it's over-predicting warming in the past, it's over-predicting warming in the future. And in fact, really, this implies a negative feedback case, because I think the number here might be like 0.4 or 0.5, which is actually even less than that. So anyway, I will leave you with that. That is why this is the basic logic that gets skeptics to the point. And there's a lot of things going on with satellites and looking at infrared radiation and feedbacks directly into space and all this kind of stuff. But this is why I, as a skeptic, initially got to my middle ground. Okay, I used to play a whack-a-mole game with all these, and we just go through all these charts. And I've already taken more time than almost more time than I should. I'm getting on my time thing. So we're just going to go quickly through these. But just take this instead of me knocking down every one of these climate effects like warming and hurricanes. Think of this more as become better consumers of information in the media. Because everything I talk about here that sort of maybe corrupt your perception of these problems are the same things that are done with terrorism and diseases and gun crime and narcotics and everything. Anything somebody wants to get you scared at, they use these same tricks. The first one is I call this publication bias. In 2001, some little boy got chomped by a shark and it made the TV. And it must have had good ratings because like every other night of that year, it was shark attack, shark attack, shark attack. It's the third biggest story in the news that year before 9/11 is they showed pictures of shark attacks every night. Time magazine has a cover, Summer of the Shark, okay? Everybody thought that this was, to this day, people my generation will all think that this was some weird, spiky, high, all-time high year in shark attacks, right? Because we had 5 deaths and 76 attacks. In the prior year, we had 12 deaths and 85 attacks. This was a down year. But everybody thought it was up. Why was it up? Because something they'd never heard in the media in the past was now on every day. And it shaped the perception that something had changed in the process, even when it hadn't. And you see this now, too. I mean, for example, the Weather Channel names winter storms. You get this badass name, like it used to just be snow. Now it's Winter Storm Saturn East Coast Beast. And so this affects climate a lot, is there's a publication bias. The second thing is, and I cannot tell you how often this happens, is just stunning to me. People will claim a trend from one data point. They will point to something. They'll say, look at that attack a terrorist attack in, was it Pasadena, wherever it happened, or Bakersfield, or wherever it was around here. Look at that terrorist attack. It just shows you terrorism is increasing. And you sort of nod your head, and then you think about it and says, wait a minute, he just justified a trend, or a change in the trend from one data point. You can't do that. And so, unless the trend was 0 before. And so, for example, this is a measure of hurricane strength, okay? It's the best measure we have because it's not just counting them, which is kind of random. It looks at the total energy of all the cyclones in a year. And so you sort of see it's a very cyclical process. You see there's no long-term trend. This was Katrina. Al Gore and everybody else said, Katrina proves that the hurricane trend is changing. We're getting more hurricanes. It did not. It was one data point. If you look at the actual trend, there's no trend. You get the same thing. You get a downward trend. The number of people who die in extreme weather events has been going down every decade of the century, both in absolute and a per capita basis. Bill McKibben in 2012 says, look, we're now seeing climate change. It's going to be drought all in the future. And in fact, this is a drought measure. The blue is non-drought. The orange is drought, really strong drought months in the U.S. And you can see, we had this bad drought in 2012, but it was no worse than many other droughts along the way. There turns out to be no trend in that. In fact, if you look at the percentage of the U.S. that's in drought conditions by year, and by the way, I'm not making these things up. This is right off the U.S. official government site. You can print them out yourself. It's actually a downward trend in the number of acres that are experiencing dry weather. So you actually have a downward trend in droughts in the U.S. I'm going to skip that chart because it takes a while to explain. But basically, you have the same thing with heat waves. People talk about heat waves all the time. We've had some higher heat waves of late, but nothing like the 1930s, and there's no real trend. If you took all these are, again, years all the way down, if you can't read those, these are the number of 100-degree days. You can see there's no trend in the U.S. in 100-degree days, except there was a spike in the good old 1930s. And here's trend in 110-degree days, and there's no spike except for in the good old 1930s. And in fact, if I'd shown the previous chart, you would have seen that most of the majority of the temperature records in the U.S. are still dated in the 30s. There's a measurement technology bias. Al Gore showed this chart in his movie. Tornadoes are taking off. By the way, if any of you are in public health and cancer, this happens all the time with cancer, a measurement technology bias. He said, look at this. We've gone from 200 tornadoes to 1,000 and 2,000, and the earth is falling apart. But if you go to, this is from the government website, if you go to this government website, right under this chart, it says, do not use this chart, because over here we have Doppler radar and we have storm chasers, and over here we did not, and we missed all these tornadoes over here. Look only at the large tornadoes that we did not miss in the 1950s. And if you look at the large tornadoes only, you will see that there's no trend upwards in large tornadoes. In fact, there's actually a downward trend, though I'm not going to claim it here. We'll just say there's no trend. What is normal? You see this all the time. People say the temperature is abnormal. Well, what is normal? One of the interesting things is we actually invented the thermometer at the depth of the Little Ice Age. So close to the coldest day in the last 1,000 years was the day we invented the thermometer. So of course we see warmer temperatures. I'll just give you one example. Glaciers are melting. This is the length of glaciers shrinking. Glaciers are melting. Since 1950, glaciers have been melting. We should blame that on global warming, except we have a problem because glaciers were melting between 1900 and 1950. And glaciers were melting between 1850 and 1900. And glaciers were melting from 1800 to 1850. So glaciers have been melting for 200 years. How do you just blame the last 50? Somehow you have to claim some process stopped in its tracks right here, and then man-made global warming took over. Same thing with sea level. Sea level is rising. It has been an almost constant rise all the way back to, if this went back far enough, to what year? 1812, into the Little Ice Age. So sea levels have been consistently rising. They're rising perhaps a millimeter faster right now. If we give that to global warming and give credit to that, that gives you 4 inches a century. And we'll skip over this. So this is what I would call the middle ground. We agree that we lukewarmers agree with 1 degree we agree with 1 degree from a doubling of CO2 from the greenhouse gas theory, but we think that the second theory of positive feedbacks is grossly exaggerated, is creating a catastrophe when one does not necessarily exist. We think that the world actually has been warmed, and maybe half of that is due to man, and we may see some of these effects in the future, but the evidence that we're currently seeing them is weak. And that's what I consider the lukewarmer sort of middle ground position that sort of never comes up in the media because I guess it's too nuanced. I'm going to end with 2 things, so I'm really getting close to the end. I'm sorry I'm over my time budget. But let me just tell you, go back to the 97%. And I think some of you may have heard these 97% studies. This was the original. So that I'm beaten over the head with 97% all the time. You skeptics are science Luddites. You're anti-science because 97% of these people disagree with you. But here's the interesting story. To be in that 97%, this is the study that got the first 97%. They asked climate scientists 2 questions. Think about how I would answer them if I had been asked them, okay? Question 1, when compared with the pre-1980s level, pre-1800s level, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? What would I say? I would say risen, right? That's what you've heard from me today. That makes me, question 1, I answered the same as the 97%. Let's go to question 2. Do you think human activity is a significant contributing factor in changing mean global temperature? What have I said? I said that human activity has probably been about half. It's probably the largest single factor. That makes it significant. I would have answered number 2, yes. That makes me and almost every major named skeptic out there who's blogging on the web, that makes us all part of the 97%, despite the fact that we consistently get beaten over the head with the 97%. We're part of the consensus. The reason is they don't ask question 3, do you believe that the Earth's climate system is dominated by strong positive feedbacks that multiply greenhouse gas warming by 3 to 5 times? And I promise you, you don't get 97% to that question, and I would answer that no, and a lot of other climate scientists would answer that no, and certainly a lot of physical scientists would ask that no. So agree here, the 97%, the questions they ask are here. This is the catastrophe, and that's the questionable part of the science. I'll say questionable, I'll be fair. So finally, on solution. I won't spend a lot of time on the solution. I do get frustrated with this whole precautionary principle that sort of says if we have any risk of a disaster, we have to go out and spend whatever it takes. We never do that. Elsewise, we'd be building space lasers to fight off future aliens and meteors. There's a lot of trade-offs. We don't have a good baseload power solution other than oil and gas right now that's that cheap. And so places like China, where 1 billion people have exited poverty, you threaten that. You threaten poverty, food supply, health, if you suddenly want to cut back on CO2, because we don't know how to burn fossil fuels without CO2. Cutting back CO2 means cutting back fossil fuels. And just to give you one thing, and everybody gets, half the people that see this chart think it's unfair, but it's a real relationship. The bottom is logarithmic scale CO2 emissions of a country. These are countries. I've named 4 of them, just to give you ideas. This is life expectancy in that country. There is a real linear relationship between creating CO2 and life expectancy, such that every 10x increase in CO2 production by a country increases its life expectancy by 10 years. And no, I'm not stupid. I don't think if I burned my Bic lighter here and created more CO2, I'm going to live a little longer, right? What this means, though, is CO2 is a marker. It's part of an industrial economy which produces more food, which produces better health care, which produces more wealth, causes people to live longer. And it's all tied together. There's a real relationship, though, a meaningful relationship that drives me crazy when people say that skeptics, they hate people, they hate the earth, they want the earth to burn. We just care about people in a different way, and we think that the cost of abatement may be worse on those same poor people than the actual warming. So, last slide, I swear. I have a low-cost solution, an insurance policy. I am tired of explaining to people why we don't need to do something because there's a solution that wouldn't cost anything, so we might as well do it. The first two parts were suggested actually by my senator, Republican Jeff Flake. The first is we have a carbon tax. I say forget all those other things. You guys at Claremont, McKenna, have the reputation of being the most economically oriented, business-oriented college in the country. I don't know if that's, y'all think that's justified or think it's bizarre, but certainly outsiders think of you that way. All the cap and trade stuff it worked okay with small coal markets. Cap and trade has never worked with CO2. It's been full of cronyism and corruption in Europe when it's been tried. There's one simple way. If you want less carbon burned from fuel, you put a tax on it, a Pigovian tax, and you let the markets and price levels and prices sort this problem out for you. You put a carbon tax on it and be done with it. You offset the carbon tax because you got to get the Republicans on board, and they're not going to be into a tax increase. So you offset the carbon tax with something else. You reduce another tax, and I would suggest the payroll tax. That's basically a tax on labor. I would even suggest, and it'd be interesting if we had any economists in the room, what they thought. I even think if you just did a pure shift of taxation away from taxing, putting a use tax on labor and shifting that to being a use tax on fuel, I actually think that would in and of itself pay economic benefits. And so you have no net tax increase. You simply reduce all the taxes on payroll and labor, the Social Security taxes, at whatever level you added the carbon tax. And then we fail all these stupid crony pick-the-winner government programs. Ethanol is a disaster. If you want to know why, I'm happy to talk about it in the comments. Wind is a problem. Solar is sort of okay. EV vehicles is the biggest giveaway to the rich of any government tax program we have. End all that stuff. In the power plan that Obama's trying to put through, let the carbon tax, let the markets, let price levels, the magic of price levels work for you. And finally, you still need some baseload power production. I'm sorry, wind and solar are not going to provide you the baseload power production you have anytime in the near future. The only alternative fossil fuels you have is nuclear. I think environmentalists were right to oppose early nuclear. I think we were playing with fire. I think now in the third and fourth generation nuclear technologies, including things like thorium reactors and passive cooling, and these much smaller reactors, I think there are much better environmentally friendly, carbon-free entirely solutions where the fuel is really cheap because we got a ton of thorium in the world. And it would be a great solution to move beyond the fossil fuel economy. Anyway, that's where I think a reasonable middle ground is, both in the climate debate and in some kind of solution for it, and I'm happy to take questions. Thanks for having me here, by the way.
We now have time for questions, so if you have one, please raise your hand, and David or I will come to you.
Hi, thank you very much for coming to speak to us today. I had a question about one of the graphs that you placed. It was the life expectancy and the CO2 level.
Yeah.
I was wondering if you could speak a little bit more about how you, drive the causal relationship, how you're certain that it's CO2 and
Right.
not another factor that could be influencing this.
It's not CO2 directly, so it's not like people breathe more CO2 out of the atmosphere or out of the power plants and suddenly they live longer. What the relationship is right now fossil fuels are the cheapest baseload fuel. They're really the only baseload fuel we have. So what you have is something's happened in your lifetimes, and you'll probably might cite the internet or something like that as the unique thing that's happened in all of history. I would say the most unique thing that's happened in your lifetimes is over 1 billion people have exited poverty in places like India and China. I mean, just staggering reduction in poverty in those countries. And that's come from their economic development and their quasi-market system there. And that's come by burning every single fossil fuel they can get at their hand. It increases their industrial capacity. It lets them have power for hospitals. It lets them have clean water. It lets them industrialize and make more efficient their agricultural sector. In all the ways, think of all the reasons why the United States, in this country, why our life expectancy is 70 or 80 years and not 40 like it was 100 years ago. Almost every one of those are tied to the availability of inexpensive energy that fuels our industrial economy. We need to find a different one. What I would rather do is have a plan where we can transition cleanly to a different one without going cold turkey, because cold turkey is going to leave a lot of people hanging. But it's that industrialization driven by cheap fossil fuels that's increasing those folks' life expectancy.
Hi. I was just wondering, and I hear people say that there's going to be like more seasonal variation, extreme temperatures, but then most of the graphs you've shown have averaged over the whole year.
Right.
So I'm wondering, if you're averaging over the year and there's more extreme seasons, like aren't you essentially disregarding that hypothesis?
Yeah, I would love to do that. Let me start with even before seasons. Let me talk about night and day. And I won't bother to get the chart out. I have like a 200 chart appendix in there, but I won't go digging through it. I'll just tell you, you've seen too many charts already. Basically, most of the warming, if you look at, I was going to tell you that we don't have daily high temperature records, and that's true. We're not having any more daily high temperature records. There's no trend in that. We're not having a lot new daily high temperature records, or more than you would expect. I mean, you're obviously, every 100 days you should have a 100-year record on average. What we do have is a trend in record high nighttime lows, if that makes any sense. So the low temperatures at night are not as low. And it's not going nearly as low as it used to be. Most of the warming we see from global warming, and this is even mostly predicted, is happening at night. And then a lot of the warming is actually happening in winter nights, and winter nights in particularly cold places like the Arctic and the Siberia. So in fact, a lot of what you're seeing is moderation. You're seeing the coldest parts of the day and year getting warmer and getting warmer faster than the hottest parts are getting even warmer. That would make things more extreme. So I may be missing something. I'm not a student of seasonal variations, but my sense is a lot of the warming is occurring in a way that actually sort of moderates things rather than make the extremes, the swings more extreme.
Hi, thank you very much for your talk. In your opinion, who do you think is benefiting the most with the current narrative? And going into the future, unless we have some big changes, we're going to keep getting this narrative. Who do you think, or what industries do you believe are the ones that are benefiting the most from it?
I'm sorry, I had trouble following the first part of that. About the narrative, who benefited from what? I'm sorry, from the current, who benefits from the current narrative, or what was the last
what
part?
industries, for example, we have the cap and trade, how there have been certain, for example, British Airways.
Right.
They've made millions of dollars off of it. In your opinion and your research, who do you think, what industries are we targeting to see the most growth in?
I think, I don't know if, I'm not smart enough to say if you put a carbon tax on who would be the beneficiaries or not, but I would be comfortable that whoever is benefiting would get the most out of it. Right now what we're getting is this real cronyist pick and choose. I mean, ethanol, you know why we have ethanol? You might want to take a guess of why we still have, everybody, I'm telling you, everybody from the left, the right, even Bill McKibben, I pick on old Bill, okay? But even Bill thinks ethanol is the stupidest program ever. Why do we have ethanol? Anyone want to guess? What? We just saw it recently, more specifically than just farmers. The Iowa caucuses. What's the first presidential primary? The Iowa caucuses. I'm not a huge Ted Cruz fan, but he did one thing that no presidential candidate has done for decades, is he stood up in Iowa and said, ethanol is stupid. All these guys, even the most free market guys in the whole world, or women, I'm sorry, I don't mean to just say guys, most free market candidates in the whole world, all go to Iowa and they said, oh yes, we will protect the ethanol program, I promise. Because I can't get anywhere if I don't have traction in the Iowa caucus. It is stupid. Ethanol is just like the, so my point of that is when you have government picking winners and losers, it becomes extremely political. People say, well, if we just had the right people in government, they would scientifically sit back and pick the optimum. Yeah, that never happens. Even if the first guy in the office does a really good job, the next person in the office is going to get captured, okay? I challenge you, look at the VA, look at I challenge you to find the government program that systematically is very science-based and makes these trade-offs right. The carbon tax works automatically. Everybody agrees it'll work. You just got to get over the Republican, hatred of supporting a tax, and you got to find a way to get them on board, and I think, the offset tax might be a way to do it.
Hi, thank you for your speech. I was wondering what you thought of the recent Paris climate conference and whether they, applied the precautionary principle too much. They were relatively good in setting limits.
First is I don't really think they necessarily applied the precautionary principle, because if they applied the precautionary principle, it would have been more what they demanded would have been more sweeping. They would have just, if you really want the precautionary principle, we should just stop entirely on CO2. Europe, by the way, is much bigger on precautionary principle than we are. That's why it's very hard to get these new biotech programs through, European, the EC. They don't really pretty much kill them all because they apply the precautionary principle to them all. And so it makes it hard to make progress in these various permission-based industries. But the Paris conference, look, I don't have the Republican disdain for having a conference about this. Clearly, there's absolutely no way for one country to solve this. It's pointless. It's just like California having its own program when the other states don't do it. I mean, it's fine for maybe setting an example, but it's pointless. And it's also pointless. Whatever we do for the U.S. is going to be pointless because China is going to go crazy. So the one thing I will tell you is this is not going to get solved. I mean, for those of you, I'm telling you, no matter what we do in the U.S., if you look at the China and India projections, they're not going to take a step backwards. They're not going to make themselves economically less powerful than the U.S. They're not going to send their billion citizens back into poverty because there'll be a freaking revolution. Okay, so they're going to burn every bit of CO2 they can get their hands on until we can maybe develop a nuclear alternative for them. But they're going to do it. We're going to have a ton of CO2, and so I'm actually happy that I don't think the downside is going to be very high because I don't think it's stoppable at this point. But from the Paris conference, I think conferences like that make sense. I mean, there's no way you can do that kind of thing unilaterally. I don't like Obama's response of trying to do this power plan program that just got struck down by the Supreme Court. I think it's another one of those stupid random programs that don't really have any cost benefit to them. But I know that he's hamstrung. He knows he can't get a carbon tax through Congress. I would love to see him try. I mean, this was proposed by a Republican, a libertarian Republican in Arizona of all places. And so, I still think it's worth a shot on the carbon tax. I think all these little piecemeal programs are just never going to get anywhere. But I think the Paris conference, theoretically, I don't have a problem with conferences like that. I mean, I don't know of any way that you're going to solve this because increasingly the U.S. and the EU are going to be irrelevant. This is a China-India thing, and frankly, I don't think we're going to stop them from burning all the CO2, all the fuels they can get. So I think we are where we are.
Thank you, Mr. Meyer, for your speech. So I understand that the media prefer a more catastrophic scenario about climate change. But from your speech, I understand you mentioned that there's kind of a spectrum of opinion in the research community about how catastrophic man-made climate change can have as an influence on the environment. And when you mentioned skeptics, I just wonder, how do you divide that in terms of the proportion of what's the percentage of researchers who believe that man-made climate change can have a significant impact on the environment, and the proportion of skeptics? Yeah.
I think that, I don't know. One of the things, if you had looked on that chart, it's gone now, but one of the interesting things that always makes us skeptics suspicious is that 97% chart. If you remembered, I showed some bars next to that. That 97% was like 75 out of 77. They took 77 responses and 75 answered those two questions. I don't know how they didn't get 100%. I mean, I answered them both yes. But they took 75 out of 77. They actually got 4,000 responses, but mostly from physical scientists and chemists and meteorologists and all people they said didn't count. If you go to for a long time, a lot of the rest of the scientific community, all they really had people have collegial respect. Their colleagues were saying it. Everybody was saying in the press that this was settled science. And so you had people I have one old professor at Princeton who would say this. He said, yeah, I used to say, I used to hammer on skeptics because I didn't know anything about it, but I accepted my colleagues who said they were being anti-science, and I believe in science, and I want to defend science, right? But then I looked into it, and I said, oh my God, there's some real problems in this. I can't believe I was defending it. So we don't know the count. The people who run the studies leave out a lot of the surveys. We're not sure what was in it. I don't want to conspiracy theory it because I don't support that kind of thing. So I'll just say we don't. But I would say that one of the problems is increasingly within the climate field, they will only, there's like a certification process now. They'll only call you a climate scientist, a real climate scientist, if you agree with catastrophic global warming. It's sort of like the loyalty oath in the door, right? And so once you start disagreeing with catastrophic global warming, suddenly you're not a climate scientist anymore. You're a physicist, or you're an earth scientist, or you're something else, right? Or a geologist, or something like that. I mean, if you take geologists all think this is utter madness. I mean, you go to the American Geological Society and they look at this and say, this is nuts. So there's a lot of skeptics out there. But again, we're not denying the greenhouse gas theory. We're denying this notion of positive feedback amplified to a catastrophe.
Hello? Oh, thank you for your talk. So my question was, moving away from burning CO2, how does your model take into account deforestation that has happened over the past couple of years?
I missed the line. How does the model take into account what? I'm sorry?
How has your model taken into account deforestation that has happened over the past years?
I've way oversimplified this. Okay, deforestation is an issue because you reduce the sink for CO2. There's a ton of other things going. There's other greenhouse gases like methane. Natural gas can seep out of wells. It can seep out of the tundra. It's really complicated. I've oversimplified just to CO2. So I've only looked at the CO2 effect. Because that's what we tend to debate. So I've narrowed it to CO2 and focus. I could fully confess there's other things in the climate change debate, other drivers. I mean, there's the whole thing about ocean acidification. I mean, I'm just don't have the chemistry chops to get into that. So I don't. So we're just talking narrowly about global warming from CO2. I will say from deforestation that there is interesting that the world is actually, we're all surprised, the world actually greened over the last 10 years. They think because of CO2 in the atmosphere, because a lot of plants are fertilized by CO2 in the air. So that you actually see an actual real greening of the globe in places like the southern Sahara that wasn't there before. So you do have deforestation issues. A lot of that's decelerating. A lot of people don't know the U.S. has been reforesting for 100 years. The trough of U.S. forestation was in 1920. So it's not deforestation everywhere. By the way, I always laugh. This is completely irrelevant to your question, but I do have to laugh at this because it's always funny, the advice you get. My local community had a Christmas tree composting station. And they said on the news that you should really go compost your Christmas tree to fight global warming, fight climate change. And I don't know if you think about that for a second, but if you think about it for a second, if you go and compost or chip up a Christmas tree, all you're doing is causing the carbon in it to basically decay faster into CO2. You're actually accelerating its turn to CO2. If you actually care about climate change, take your Christmas tree, shrink wrap it, and bury it 8 feet deep, and then you've sequestered some carbon and you've done the Earth a favor. What else?
Actually, unfortunately, that's all the time we have for questions tonight. But please join me in thanking our speakers tonight.